James Webb, the most powerful space telescope humanity has to peer deep into the cosmos, is now a little over a year old. And to properly celebrate this anniversary, I suggest we dive into the most striking images captured by this time machine, which, equipped with a massive primary mirror, 6.5 meters in diameter, drifting through space 1.6 million kilometers from Earth, is capable of photographing some of the oldest and most distant objects in the known universe, such as capturing planetary systems in formation and the planets of our solar system as we've never seen them before. In short, today we're going to explore images heavier than 100 trillion suns-observed stars being born and others on the verge of dying, and even fly over extraterrestrial asteroid belts. And since this episode is dense, to follow a certain logic, I'll start with the most distant objects that James Webb has managed to capture and gradually move closer to our galactic neighborhood. Let's go for a mind-blowing journey through just over a year of fantastic image discoveries that we'll try to understand and decipher together. Here is one of the sharpest images ever taken of the early universe. Captured by the James Webb, it shows us a tiny portion of the deep sky with a foreground cluster containing hundreds of billions of galaxies located about 5 billion light-years away from us. And behind it, thousands of others much, much farther away. And among these are hidden some of the oldest galaxies we have ever observed. Here is Glass Z13. Remember its name because this slightly blurry glow, captured by James Webb, lets us see a galaxy nearly 13.5 billion years old, and now you can forget its name. Because with Webb, the discoveries of older and older objects are likely to happen, and in the coming years, you will see countless publications about galaxies with strange names that will have their brief moment of fame. Because one of the great strengths of James Webb is its ability to go back in time, letting us see objects as they were 300 million years after the Big Bang. Indeed, thanks to its extreme sensitivity in the infrared range, this telescope allows us to observe objects whose light has shifted out of the visible spectrum. Because on the large scales of the cosmos, with the expansion of space, the farther away the objects we observe are, the more the light that reaches us seems tired, gradually shifting toward the red. And by doing so, the James Webb allows us to discover objects located deep in cosmic time, and above all, to uncover some of their mysteries much more clearly. Because even though the Hubble telescope had already trained its mirrors on galaxies just as distant in space and time, the important thing to remember here is that each of the spots observed by the James Webb is full of much more promise. Since by breaking down the light, we can learn a great deal about the chemical composition of the objects that emitted it, whether stars or galaxies. To understand in more detail why light is such a powerful key to deciphering the universe, I recommend this episode here. In any case, since the nature of the light spectra coming from galaxies is much closer to us and relatively well known, with Webb we will soon be able to compare the differences between those that are very distant and those that are close, and thus trace the history of their evolution, from the early universe up to today. And here, I'll take a quick detour to give you a sense of the sheer power of the James Webb. Here is a small portion of the dwarf galaxy WLM, located about 3 million light-years from here, as observed by Webb. What these pictures don't tell us is the exposure time needed to capture them. You probably know this image, one of the most extraordinary ever taken by humans, called the Ultra Deep Field, and we owe it to Hubble. It shows us a tiny piece of the sky, about the size of a pinhead held at arm's length. So, it would take about 23 million photos like this one to cover the entire night sky. And within this tiny portion of the sky, Hubble was able to reveal the existence of nearly 10,000 galaxies. To capture this single image, the telescope had to focus on this region of deep space for a total of 11 days. In 2022, Webb took less than 24 hours to observe this same region of the sky in high resolution, while also revealing the existence of galaxies whose light was too faint to be detected by Hubble before. And with that, I now invite you to go and be truly amazed. With this snapshot from Webb, which captured, in a cluster of galaxies located 6.3 billion light-years from Earth, an impressive gravitational lensing phenomenon that doesn't make us see double, but triple. These distortion phenomena are not the result of wild hallucinations. They occur when a powerful gravitational field in the foreground distorts and amplifies the light from background objects, thus creating these kinds of cosmic mirages. Astronomers are so interested in these strange luminous arcs that occur when large amounts of matter come together. It's like bending the fabric of space-time to the point of curving light rays on a large scale. It's because these distorting lenses can act like gigantic magnifying glasses, letting us see what's hidden deep inside. Thanks to these lenses, the light intensity of distant galaxies in the background is amplified. And this magnifying effect they have on extremely distant objects gives us the chance to observe phenomena that would otherwise remain imperceptible, such as the birth of the universe's first stars. And by closely studying these magnifying gravitational lenses, we can even get an idea of the hidden distribution of mysterious dark matter on the large scales of the cosmos. And now, I suggest we take a little detour through some of the most beautiful pictures of galaxies captured by Webb this year. The Cartwheel Galaxy, whose immense rings can be seen 500 million light-years away from us, with a resolution unmatched until now. Eventually, the observations gathered by Webb should allow us to learn more about the sometimes turbulent history of these giants of dust, stars, and gas that are galaxies. These likely get their strange shape from a past collision with a smaller galaxy, which, by passing through it, would have pushed away a large part of its matter. Thus, it is believed that the Cartwheel was, several tens of millions of years ago, a spiral similar to our Milky Way, before a terrible collision at the galactic center triggered the spread of a huge concentric shockwave, like a stone dropped into water sweeping away gas and interstellar dust in its path, until it caused the formation of a ring on the outskirts, richly endowed with massive, young, and extremely bright stars. The composite is the largest ever made by James Webb so far, covering about 1/5 of the Moon's diameter in the sky. You can see, locked in a high-resolution cosmic dance, the galaxies of Stephan's quintet, of which only 4 are actually close to each other. The one on the far left is 40 million light-years from Earth, while the other 4 are about 290 million light-years away from us. This region of the sky is a fantastic laboratory. The fundamental processes of interaction between galaxies. Here, researchers can closely observe how the gas clouds of these giants are disturbed by the imposing presence of the others, and to what extent this kind of cosmic dance triggers the formation of bursts of star formation. And here, it should be remembered that the James Webb, as powerful as it is for infrared observations, is still just one tool among others, and it often makes the most sense when its images are combined with those produced by other telescopes. These images of the spiral galaxy's core show this. Located about 17 million light-years away, and which can be seen emerging behind thick clouds of gas and dust. Particularly bright regions of star formation, here successively observed in ultraviolet and visible wavelengths by Hubble, then in infrared by Webb. And finally, through all this combined data, in order to learn more about these enigmatic regions where stars are born. To really understand why this single telescope does not give us access to all the phenomena occurring in the universe, let's take a very concrete example. Here is the image of the deep field I mentioned at the beginning of the episode, as seen by Webb. And now, here is the same image combining this infrared data with that from the Chandra telescope, which observes the universe in the X-ray range. And from then on, in this image, you can see a gigantic blue cloud appearing, which, overheated to temperatures of tens of millions of degrees, is only visible in X-ray light. Now, this vast expanse of diffuse gas that James Webb is unable to see is anything but insignificant. Because with its total mass of about 100 trillion times that of our Sun, it outweighs all the galaxies in the cluster combined. Much closer to us, here in our galaxy, only 8,500 light-years away from us, is a very small part of the Carina Nebula, observed successively by Hubble and by James Webb. And what is particularly striking here is the ability of the Space Telescope to visually make interstellar clouds go from opaque to transparent. By piercing the winding dust layers of these astonishing landscapes, whose vastness is truly gigantic and whose heights are measured in light-years, James Webb reveals the presence of hundreds of stars that have just been born. These stars, still buried under the immense clouds of gas and dust that gave birth to them, are only about 50,000 to 100,000 years old, a blink of an eye on the scale of cosmic time. Thus, James Webb's keen infrared vision allows us to observe the very earliest stages of a star's life up close. As shown to us in this image of the now legendary Pillars of Creation, where the telescope's piercing view, giving us access to the depths, reveals, buried within this nursery, the presence of stars in the process of forming, and which, tempestuous, sculpt the pillars from the inside with great force, powerful ultraviolet radiation and stellar winds. Here, you have to understand that the image we are observing is a composite image, a blend of two different shots taken by James Webb, which is sensitive to several infrared wavelengths. Observed in what's called the mid-infrared, the Pillars of Creation seem to plunge into a shadowy atmosphere, and we mainly see aging blue stars there. Because most of the wavelengths detected here struggle to penetrate from inside the thick layers of gas and dust. While observing the same scene in the near-infrared, the opacity of the pillars fades, taking on a rusty red hue, revealing thousands of stars beneath the layers of gas that are only a few 100,000 years old. As for these strange red spots, they are produced by ejections from young turbulent stars, and which, buried beneath the tops of the pillar, periodically propel material around them, and at high speed burning gas that will eventually crash onto the edges of their immense cocoons within which they have ignited. Before we leave the Pillars of Creation, I'd like to remind you of their incredible size just to appreciate their sheer scale. Each of these columns is nearly 5 light-years long and is heavier than 1,000 suns. The tiny drops of gas and dust that are suspended at the top of the left pillar are each larger than our entire solar system. For a probe like Voyager 1, which is currently speeding through space at over 61,000 km/h, it would take nearly 25,000 years to travel from the base of one of the pillars to its top. And yet, as vast as it is, this stellar nursery is relatively small compared to the one we're now zooming toward, which spans an area nearly 100 times larger than the pillars. Here, immortalized by Webb, is the Tarantula Nebula, the brightest star-forming region that can be found near our galaxy. Within this fantastic cosmic landscape of pillars, ridges, and valleys, tens of thousands of stars are gathered together at practically every possible stage of life. From their embryonic stage, when they are still wrapped in cocoons of gas, to the giants, which, being too massive and after burning through their fuel at a furious rate, inevitably end their lives in cataclysmic explosions known as supernovas. Here, the particularly sparkling region of the image, the boiling crucible, named NGC 2070, contains about 500,000 yellow stars, some of which, nearly 100 times heavier than our Sun, have carved deep cavities in the surrounding matter with their radiation. Consider that all the layers of dust and gas found here contain more than 500,000 times the mass of our Sun combined, an impressive figure that might make you think these formations are extremely dense. But the eye can be deceiving because, as opaque as it may be, a vast cluster of interstellar gas and dust like this one contains on average only a few thousand molecules per cubic centimeter. A ridiculously small number compared to the 20 billion found in the same cubic centimeter of air on Earth at sea level. To try to visualize this difference in density, imagine that the volume of an Olympic swimming pool filled with air contains roughly the same number of molecules as the volume of 3 times our planet in one of these nebulae. Now let's leave this gigantic cluster and head toward the Ring Nebula. A structure a little over a light-year across, already immortalized by Hubble, but now enhanced by Webb, revealing all its subtlety. Sheets of turbulent gas. Ejected not long ago by a dying star located at the center of the image, the layers it shed are now dissipating into the surrounding space. If you're interested, I made a whole episode about this type of nebula. Here, unlike Hubble, you'll notice that Webb is even able to reveal many galaxies in the background. The image I'm going to show you now is one of those taken by Webb that moved me the most, maybe because it allows us to witness the very first moments of a star's life. In fact, the star rising at the center of this hourglass of light is so young that astronomers consider it not really born yet. in the sense that, at its core, the nuclear fusion processes that make stars hum haven't started yet. IL 1527, as it's called, is therefore a protostar located about 450 light-years from Earth. And James Webb even made it possible to estimate its age, only 100,000 years. At the center, the nascent star will continue to grow, feeding on the molecular hydrogen that surrounds it, and which, caught in intense turbulence, will eventually spiral back down. At the center, where a dark and opaque accretion disk with a diameter about the size of our solar system hides part of the light from us. In this plane, where matter gradually comes together, planets could very well form in the future. In the meantime, if you lean over this stellar cradle, you could almost hear the howls of L 1527, whose faint light illuminates the surrounding dust and gas from within, like powerful beams of light pointing in two opposite directions. And now, here is another dusty disk surrounding a star, this time at a more advanced stage of formation. Let's be honest, from a purely aesthetic point of view, the image is a bit ugly. But the story it tells is splendid. Because James Webb shows us here a debris disk, which is thought to have formed around the star by repeated collisions of planetesimals. In other words, this cloud of dust and rocks within which, using other telescopes, the presence of two planets has been detected, offers us, in a way, a time window, giving us a direct view of the very first moments of a planetary system in formation. In this other image, where the powerful light of the star has been masked using a coronagraph, the James Webb shows us, in stunning detail, 3 extrasolar asteroid belts. Here, it is believed that these belts, stretching over 23 billion kilometers around the star, which is 150 times the distance from Earth to the Sun, have been shaped by the gravitational forces of young planets in this system, likely in the process of clearing their orbits. In short, as you can see, the study of exoplanets, meaning planets orbiting stars other than our own, is at the heart of the telescope's objectives. And before diving into the discoveries made over the past year, let's take a little detour through the planets of our solar system, as you've most likely never seen them before. Starting with Jupiter, which, when observed in the infrared spectrum, is both enhanced and transformed by the gaze of James Webb, allowing us to see the gas giant streaked with storms and surrounded by violent winds, taking the form of swirling horizontal stripes that sometimes mix together, just like cream in coffee. Here, the clouds that strongly reflect sunlight give the turbulent great red spot shades of white. Meanwhile, the electric blue auroras produced by the interaction between the planet's powerful magnetic field and the charged particles from the solar wind shine brightly at the poles. In this image, you can even make out a faint, subtle ring encircling the largest planet in our solar system, appearing as a pale white band that barely stands out against the darkness of space. And now here is the gas giant Neptune, with the image taken by the Voyager 2 probe in 1989 during its flyby, along with the photo taken by Hubble in 2021. And finally, the one recently taken by Webb. By showing it in infrared against the vast background of space, it powerfully highlights the presence of methane ice clouds in the form of extremely bright spots on the lower half of the planet, as well as thin rings and several small moons. Here, the power of James Webb is such that the background stars located in our galaxy are accompanied by hundreds of other galaxies, which are extraordinarily farther away. Uranus is not left out either. Because Webb, in just 15 minutes of exposure time, made it possible to clearly distinguish 11 of the 13 rings encircling the planet, while also revealing again, in addition to a few stars in the background, many distant galaxies. Finally, here is Saturn's largest moon, Titan, still magnificently captured by Webb, one of the most fascinating satellites in the solar system, since it is the only planetary body, other than Earth, to have rivers, lakes, and seas on its surface. All of them are hidden by a dense atmosphere, within which James Webb was able to detect the presence of hydrocarbon clouds. In the future, with more observations, the telescope should be able to teach us more about the climate and seasons of this mysterious world. And now, we're going to take a little tour among the discoveries that the telescope has made possible regarding exoplanets, that is, worlds orbiting stars other than our own. And here, it should be immediately clarified that, unlike the images I have shown you so far, which are all real photos taken directly by the telescope, for the next 4 cases, we will have to use artists' illustrations, because these observations were all made indirectly. To begin with, James Webb managed to extract light coming from the atmosphere of WASP 39b, a gas giant the size of Saturn, closer to its star than Mercury is to the Sun. And thanks to this light spectrum, the most detailed ever obtained so far from an exoplanet, Webb made it possible to reveal the presence, in the cloudy atmosphere of this alien world, of water, sulfur dioxide, carbon monoxide, sodium, and potassium. In the light coming from the exoplanet WASP 87, another gas giant with an overheated atmosphere, traces of water, most likely in the form of mist and clouds, have been detected. By observing the rocky exoplanet TRAPPIST-1b, Webb was able to estimate its temperature on the side that is perpetually exposed to the angry little red dwarf star it orbits, at around 227 degrees. Clearly on that world for life things look pretty grim. But TRAPPIST-1b is the planet closest to the star, and 3 of the other planets in the legendary TRAPPIST system appear to be in the habitable zone, meaning at a respectable distance from their star to possibly have liquid water on their surface. So, it's one to watch. Then, by analyzing the faint light coming from the exoplanet VHS 1256b, Webb made it possible to confirm that this gas giant, although it is 4 times farther from its pair of stars than Pluto is from our Sun, has a scorching atmosphere with extremely marked changes in brightness, and its temperature has been measured at around 830 degrees. And then, by breaking down the light spectrum coming from this planet, Webb was able to detect in its turbulent upper atmosphere the presence of water, carbon monoxide, methane, as well as potential clouds of dust and burning silicate grains. In other words, fine sand, nearly 3 times hotter than the inside of an oven set to about 500 degrees Fahrenheit. Finally, to top it all off, the telescope was even able to capture a direct image of an exoplanet. Here is HIP 65426b, a gas giant located 350 light-years away from us, and 6 to 12 times more massive than Jupiter, as seen by the James Webb in different ranges of infrared light. Finally, to wrap up this overview of the most beautiful images from the telescope's first year of activity, here is a cosmic fingerprint telling us a terrible story written by the stars. In this image, you can see a strange structure drawn in the sky, made up of about 15 concentric dust rings, surprisingly regular, and located 5,000 light-years from here. It is believed that these patterns were produced by the pair of stars at the center, one of which is a Wolf Rayet, meaning an extraordinarily massive, unstable star that almost continuously emits powerful stellar winds. And since the respective orbits of the 2 stars bring them dangerously close every 8 years, the more turbulent of the 2 stars. See, these outbursts become destabilized. And it starts, seemingly to pulse in space with the regularity of a metronome. Consider that here, it's believed that nearly half of the mass of the unstable giant has already been propelled into space by this astonishing process that James Webb allows us to capture. And everything I just talked about was observed in barely a year, so yes, I left quite a few things aside. I could have, maybe I should have, focused on the technological feat required to deploy in space a telescope whose primary mirror is so large that it can only fit folded inside a rocket's fairing. Talk to you about the staggering distance that separates our planet from this telescope, as well as the strange orbit it has around our star. But in this video, I chose to focus mainly on the beauty that James Webb allows us to reveal, and on some of the still wide-open questions that the telescope's sharp eye allows us to tackle. I hope you'll forgive me for that. With that, it's almost time for the Night of the Stars.